Now in the second video of this lecture number 13, which is about medium access control, uh, we will discuss the second category, that's the dynamic assignment contention free protocols, and the first technique, which is the pooling process. So again, and another, that the token passing and the reservation based. So what is token passing? That it is station passes a pooling request to each other using a special frame which is called a token, and then a station is allowed to transmit data only and only and when it holds that token. And when there is finally, when the reservation based protocol use that time slot in order to allow nodes to reserve future access to the medium access base that is based on demand. So a node can indicate its desire to transmit data by toggling a reservation bit in a fixed location. So it's a very complex protocol, and it requires communication and computation. So when considering it for wireless sensor network, so we need to consider the limited battery, the very limited memory and computation. So this have some reservations. Now the contention based protocols is again another type of MAC protocols that allows the nodes to access this shared medium simultaneously, but there is always a danger or a risk of collision, so the mechanisms needs to control the collision process. So the mechanism has to reduce the number of collisions, and it has to recover if any collision occur from such collisions. So Aloha protocol is one example of the contention based MAC protocols that uses acknowledgement to confirm the success of the broadcast data transmission. So what is Aloha? And the nodes access the medium immediately, simultaneously, and addresses collision when the approach is such as exponential backoff occurs, and it increases the likelihood of successful transmissions. There's another flavor of that's called the slotted Aloha protocols that tries to reduce the probability of collision by requiring that a station may commence transmission only at a predefined points in time. So the transmission is only restricted when to a particularly predefined points in time. So in this way, the collision can be avoided. This flavor of Aloha protocol increases the efficiency of Aloha because it's the synchronization among nodes is best addressed. And another contention based protocol is the CSMA, which is a very popular contention based MAC protocol, and its variations include the CSMA CD, which is the carrier detection, and then the CA, which is the carrier avoidance, carrier sense multiple access collision detection, and carrier sense multiple access collision avoidance. So how this protocol works, that the sender first sense for an ideal or a busy medium, and then if it is busy, the medium is busy, the sender stops and refrains from transmitting packet. However, it is ideal, the sender decides that it should start data transmission. In case of wired system, the sender continues to listen to the medium to detect collisions if it's on data and other transmissions. However, in case of wireless systems, the collision always occurs at the receiver, and the sender will therefore is unaware of the collision because the sender is at a remote location. Another popular contention based protocol is the carrier sense multiple access. We have already discussed, and there's a hidden terminal problem. That's when two senders, that is A and a C, they are able to reach a receiver B but cannot overhear each other's signals. So this is a hidden terminal problem. You can just look at the diagram that the A and C receive are reachable from B, but the A and C cannot hear each other. So A and C needs to transmit data to B at the same time. That can result in causing a collision at B, and both A and C will not detect this collision. So there's another problem, which is the exposed terminal problem, and where C wants to transmit data to D, but decides to wait because it is already overhearing ongoing transmission from B to A. So B transmission will not interfere with data reception at D, since D is outside the transmission of range of B. However, that D waits because it overhears that there's ongoing transmission between B to A. So A's consequence node C's decision to wait delays transmission unnecessary. So there's a delay. So many MAC protocols for WSNs are basically designed to address these two problems, that the hidden terminal and the exposed terminal problem. So they are addressed in most of the MAC that are customized for WSNs. So let's discuss some wireless MAC protocols in further details. So the first, carrier sense multiple access. There's a difference between a CSMA and Aloha that we already have discussed in the previous slides, that in CSMA, nodes first sense the medium before its transmission, and that reduces the collision. And in case of non-persistent CSMA, the node is allowed to immediately transmit data once it identifies that the medium is ideal. However, if the medium is busy, the back-off operation is performed, that the node waits for a certain period of time before it again transmits that data. However, in the one persistent CSMA, a node that is wishing to transmit data continuously sense the medium for activity once the medium is found idle, and the node transmits its data immediately. If collision occurs, the nodes wait for a random period of time before attempting to transmit it to you again. However, in case of P persistent, the node also continuously senses the medium, but it transmits data with a probability P once the medium becomes ideal. So there is again a delay in the transmission, and this delay have a probability of 1 minus P. Now, multiple access with collision avoidance and MAC-RW, that's again rely on the dynamic reservation and such as some packets like RTS or CTS, which are the ready to send packets or clear to send packets, are used in the MECA. And with the ready to send, a sender sends sender device shows its desire that it's going to transmit data to intended receivers, and if the receiver sends the RTS and it arrives at the sender, the receiver is ready to receive the packet and it's respond with a CTS control message. If the sender does not receive a CTS from the receiver, in response it will retry at a later time. However, if the CTS message has been received, the channel reservation has concluded successfully, so it will start transmitting. Other nodes that are hearing that entirely RTS or CTS messages, then they came to know that a data transfer will about to be occur, and they will wait for attempting for transmission or reserving for the channel. So using this RTS and CTS handshake, the MAC address addresses the challenge of the hidden terminal problem, and it reduces the collisions by reserving the medium for data transmission through this handshake. Now there is another wireless MAC protocol which is MECA by invitation. Here the destination device initiates that transfers by sending a RTR which is a ready to receive packet to the source. So the initiation takes place from the receiver, and then the source who wants to send that data, they respond with a data message. Now comparing it to MECA by invitation, it reduces the overhead, thereby it increases the throughput, but it depends again on the destination who knows when to receive data. So source nodes can use an optional field within the data message to indicate number of queued messages, thereby the destination with an indication that more RTS packet will be required. Now there is another very popular standard we already use is the IEEE 80211, and that's published. This IEEE published this standard in 1999. That's commonly known as the wireless fidelity Wi-Fi, and it basically is the combination of the CSMA CA and MACAW concepts, but it has extra features of preserving energy, and that can be used in a point coordination functions or distributed coordination functions mode. So in the point coordination function mode, devices goes through a access point which is a central entity, or the devices goes through a base station. However, in case of the distributed coordination mode, the different devices directly communicate with each other, and this is an ad hoc mode based on the CSMA and CA. This protocol first sends the medium for activity, and if the medium is idle, or at least a time period called the DCF interframe space exists, the node is allowed to transmit. Now if the medium is busy, a backoff algorithm is executed and the transmission is deferred for a certain period of time. The algorithm have a random selection of the time slots, and it waits and stores the backoff counter value, and for every time slot that passes out activity on the network, the counter ID is incremented. Now the device can when this counter reaches 0, the device can attempt transmission, and if the activity is detected on the network before the counter zeros, the device waits until the channel becomes ideal for a period of for a certain period before it continues to decrement the counter value. So if the counter reaches 0, it starts sending, but first of all it will before transmitting, it will sense the medium. However, before reaching its counter, if it's found that some transmission ongoing place, so it will execute the backoff function. So after successful transmission, a receiver device responds with an acknowledgement after waiting for some time, which is called the shorter inner frame space. Now this is the IEEE 802.11 median access control diagram, which we have discussed, that once a node A makes a reservation using the RTS or CTS control message, then another neighboring node B will overhear this message, this RTS message, and it will not transmit in the medium until and unless the node A's transmission has completed and it's acknowledged that it have completed its transmission. So the another wireless MAC protocol is the Zigbee and IEEE 802.15.4, and it's basically designed for a low power devices that operate in 868, 915 and 2.4 gigahertz and megahertz frequency bands, and it have a very limited data range that stands up to 20, 40 or 250 kbps, and it's very modest as compared to the Wi-Fi fidelity that offer a large amount of data. That's up to the 54 mbps. It's up to the, this protocol supports devices with a data rate of kbps. So before this standard was developed, the Zigbee Alliance was worked on a low cost communication technology for low data rates and low power consumption. And however, after the merger, after the combined effort of Zigbee and IEEE, so Zigbee have become the commercial name of the IEEE 802.15.4 technology. So it have again further two topologies modes, that's the star and the peer-to-peer mode. In star topology, it's similar to the Bluetooth technology, where all the communication occurs through a PAN. It's a personal area network coordinator, and in this type of network, they are free. Devices or nodes are free to communicate directly with each other. However, they must associate with the PAN coordinator. So they need to take permission from the PAN coordinator before they can participate in any peer-to-peer communication. So at the last, we'll discuss some characteristics of MAC protocol in wireless sensor network, and most of the MAC protocols are built for fairness, and that's already know that everybody should get an equal amount of resource and no one should receive special treatment. However, in a WSN, all nodes are cooperative to achieve a common purpose, and therefore fairness is less of concern, and instead the wireless node are mostly concerned with energy consumption, which is the very important considerations, and sensing application may value low latency and high reliability or fairness. So these are some of the challenges for wireless sensor network if we are considering the MAC protocols. So some of the characteristics of MAC protocols in WSNs includes the energy efficiency constraint, the adaptability, the reliability, the scalability, and the low latency and predictability. So let's have a quick review about the different characteristics. So the energy efficiency. So nodes operate using a very limited resource. So we need energy efficient protocols, and that have a feature of dynamic power management, and that should address the different states of the sensors, that's active, idle, and sleep state. And the modern radios have the facility of adjusting their transmitting power. However, in keeping in view the scalability issues, that the WSN rely on multiple hop and peer-to-peer communication without any centralized coordinator, and it consists of thousands of sensors. So that needs to be coordinating this multi-hop communication in an effective way, so that the resources can be efficiently used without creating occurring and unacceptable overheads. Regarding the protocols, protocol must not are heavy duty. It must not have excessive computation burden, and must not use too much energy to save state of the information. And regarding the adaptability, the MAC protocol needs to be self-managed because it's deployed in an unattended environment, and it should be effective in case there is change in the topology or network, so it can adopt it's according to that. And regarding the latency and predictability, the data that is sensed needs to be collected, aggregated, and delivered, and that must be delivered in a certain period of time, so they within a certain latency constraint or deadlines. That's most important. And lastly is the reliability, that the network should recover in case of errors, and it should detect errors and recovering from the transmission errors and collisions. And these are some of the main concern of the link layer protocols. So these are some of the outline we have discussed in details. about the medium access control, and we discussed about the type-on, the wireless sensor. So we discussed about the two different types of the medium access, which are the contention free and contention based, and some categorization, and we discussed about the different concerns and different operations of the wireless macro protocols. That includes the carrier sense multiple access, the MACA and MACA-W, and then a different flavor, that is MACA by invitation. And then we discussed some the Wi-Fi, that's which is the IEEE 802.11 standard, and then the IEEE 802.15.4 and Zigbee, which is for low powered and low communication devices. And at the last we discussed the characteristics of MAC protocol, that includes adaptability, reliability, scalability, latency issues that are of key importance while designing a MAC protocol for wireless sensor network. And this is the reference from which the content have been taken, and you can further consult this book and this chapter for further details. And thank you very much for patiently listening. Take care. Allah Hafiz.